Hello, thank you all for coming. So the talk is Agile Data Science, building full stack data analytics applications with Kafka and Spark. About me. Can you hear me? All right, I had a startup and it died, so now I'm a consultant. And I sort of serve as data engineer, data scientist, visualization engineer. I've written some books, and now I'm doing training as well. There's a book, this is sort of based on Agile Data Science 2.0. It's out in pre-release on O'Reilly Safari. I think it's out in May officially. I turned this into a video if you want to learn how to do what we talked about tonight. Last one, I swear about me. I'm a consultant. I do product and app dev, big data app dev, and training. So very briefly, I'll cover the theory of this sort of agile data science thing. Mostly I'll focus on application development. So data products or data science. I actually believe that building apps is a fundamental skill for a data scientist, and that every line of code a data scientist writes should be a tutorial on doing that thing, and everything he presents should be an application. So to me, they're the same thing. Some of my book reviewers actually questioned this, and so I did a survey on Twitter yesterday, and so about half thought it was at least a middling amount to do with data science. So some support for this idea. And so why data science and big data? I think if you're a data scientist and you build a model or a little app and they have to rebuild it to deploy it, to get it into the business process, to really make change at the company you're working at, that you've done something really wrong. So I think you should be using big data tools. As I'll show you, they're not really less efficient, and you can use them on your own computer. So the goal of the methodology is to document and guide exploratory data analysis to discover and follow the critical path to a compelling product. So what is a critical path? There's this thing, critical path theory. You might have seen like Gantt chart, PERT chart. Critical path was like the next iteration of that, where you have to just sort of figure out a path to get where you're going. It's not necessarily linear. And so that's very important when you're building analytics products. There's a manifesto for Agile Data Science, but I won't go over it. It's about iteration a lot. There's a data value pyramid that sort of structures the talk. So the first thing to do is to plumb records through from end to end, from the way you're collecting them onto the web in an app. And then you can start with, this is now tables and charts. So you can start sort of cleaning, aggregating, visualizing, and asking questions. Up next, you sort of turn those into reports. So you extract entities, which I'll show you, and sort of link between them, add search, and you've sort of got interactivity and reports. You can drill down, etc. By the way, these are ordered in the order in which people will pay for them. So people will pay for this, but they'll pay more for that, and ultimately what they want is this. So up next, predictions, curate, recommend, understand, and people love it when you predict the future, and if it's a thing that they care a lot about. But ultimately, what people care about is enabling new actions. So that's why AI is now the hot thing, whereas machine learning used to be. So the tools that we use. I used to be a pig fanatic. It was good to see that Cask uses pig or used pig. But Spark seems largely to have replaced it. Hadoop in general. If you can be working on Spark, you probably should be. And most people want to be because you don't have to wait 5 minutes for a simple, the first line of the next thing that you were looking at. And PySpark, to me, has replaced Pig, which was in the first edition of this book, because it's a great API and it's Python. Python has really powerful tools for manipulating data in the first place, so you sort of get the best of both worlds. But batch is not good enough for many use cases anymore, so Kafka is the way people are collecting data, but it's also the way that they're acting on data in real time, or really sub-real time, because it can take a few seconds to get the worker to respond to the task. sold more books if I used Cassandra. I sort of wish I had. But I was so used to LinkedIn Stack where you could push a data set from Hadoop to Voldemort, their in-house key value store, in one operation, that at the time, there was no way to do that in any other database. And so I had to write the ability to do that into MongoDB. And it was so simple, I actually could pull that off. Because everything in Mongo, if you look at the code, it's like, oh my God, they do that. And so, but as a document store, it's like incredibly capable. Any database in existence, including like, what's the tiny SQL DB?
SQL Express.
Yeah, any of those can act as the database for this app. So it can easily do it. For search, ElasticSearch is sort of the Hadoop or Spark of search. It's awesome. It's really easy. It doesn't get in your way. And then there's a number of web frameworks, sort of like Ruby's Sinatra. Flask is one of them. I love it because there's a plugin if you need to do anything, so you don't have to reinvent the wheel, but that is not enabled by default, that you have to learn to get something done. So you just define your web app very simply and it works. And so the way the flow of data processing here works, we collect events with Kafka, we save them to HDFS, or if you're in the cloud, something like S3. We process these in batch refine them with Spark, publish that to MongoDB, present that with Flask in a browser using Bootstrap. Bootstrap is amazing. It's not on here, but before Bootstrap, everything I made was really ugly. Now it's just kind of ugly. It's not my, I mean, it's my fault. I could get like a style, Bootstrap plugin and apply it, but I usually don't. As far as Spark goes, it's a beautiful ecosystem because you get Spark and there's Spark SQL, which I'll talk about more. You get SQL now without having to use separate tools like Pig and Hive. You get Spark MLlib, which is very competitive with scikit-learn, which is a lot of people use on single node context. And you get Spark streaming, so you get to share code between these things, which is incredibly valuable.
Can I ask a question?
Yeah.
So the Spark ML you're using instead of scikit-learn, or? In
the book we do both, and then so I've got lines of code for each to accomplish a given task, which I'll show you. But yeah, I do one chapter in both, and then move on to like just using Spark MLlib because it became clear that it was the thing to use.
So you're saying Spark ML is better than scikit-learn?
I find it's very competitive and it works with many machines, so yeah. So I was a very big NoSQL guy because I just got to hate SQL trying to do everything in it where it didn't really fit. And so, whether to do SQL or NoSQL in the old presentation was a very big thing. SQL, when you get complex like this, gets really ugly. And I can't follow it. I can only do like one subselect before my brain vomits. And, but there's data flow programming, which is good if you're doing something complex. This is like Pig. This counts email addresses between email addresses. And so it's good that it's sort of broken out. But with Spark, you get to do SQL and data flow programming. So here's data flow programming until we want to do a select filter, which is very convenient, and now we're using SQL. And here we do a count. It's not a group by because we're looking at all the data, but it counts and rounds things. Backend data flow programming to plot a histogram on that data. Like it's incredibly powerful to be able to do both. I was in love with Pig, but when I first used Spark, I almost cried because I'd been waiting 5 minutes for my life for 5 years, and it was just joyous. I'm a big fan, total fan. So the data that we work with in this application is FAA on-time performance data. It's in the data flow, collect events. So there's a great website on this data where there's a rigorous description of everything, but 90 to 95% of flights report their on-timeness to the FAA and why they were late. So one of the early analyses I did was like, why are planes late usually? And it's usually the carrier's fault. But there's a whole lot of categories in there, like someone getting sick, so it's not their incompetence necessarily. Probably most of the time it's not their incompetence. Actually, the most likely reason a flight is late is because a previous flight has been late. So this is the first group by that I ran. But this data is really cool. There's tons of fields, you know, to do with, but these dark ones are the ones we sort of use. And then there's the openflights.org database. They give you information on airports, airlines, and routes, which we employ. And then we scrape the FAA registry. This data is on the website, but you can't download it. So I actually didn't put this script in the code. For the code, by the way, for all this is free, and you can play with it. It's on the link at the end. But so I scraped it, but I didn't include that in the scripts for the project because I didn't want the site to go down. So I just let you download the result. But so we scrape FAA tail number data. We use Python's Wikipedia module to pull in descriptions of airlines and that sort of thing. And I thought this was going to go down when Trump became president, but it's still there. I tested it today. Weather data is available. Because of climate change, weather data is available in very convenient formats for the last decade or 2 decades, or so some of it goes back further. I love this image. Oh, it exported as low res. This guy, I looked for climbing, and he's like in a suit climbing. He's going to do business at the top of the mountain. I think that's awesome. Don't question it. So climbing the stack. So working our way up the data value pyramid for the app. We start by plumbing the system from end to end. So what we do is this is sort of, we collected data, now we're processing and publishing data to a distributed store, which is MongoDB. Publishing flight records to MongoDB and Spark looks like this. This is a helpful module that you import. You load the Parquet file, which is a great columnar format. So you don't have to sort of use things like Avro, which rigorously define fields. You can just sort of store things, convert JSON to this columnar format, which automatically compresses it in the same way that you would have gotten with like a star schema. So star schemas are obsolete because of these great formats. And then you have to, because a data frame is the new thing in Spark, the old thing was an RDD, so you have to convert to that and then you store it. And publishing records to Elasticsearch is, again, 2 lines. This time it's just 2 lines of code. One of them is really long. I did have to figure this option out because it overloaded. It's very easy to, the caveat here is it's 1 line, but if you have like a 100-node Spark cluster and a 2-node MongoDB cluster, you need to think before you use these 2 lines of code. But in this case, they're all local, so who cares? But I did have to set that option. And so putting those records on the web, there's some Flask imports. We import PyMongo, the Mongo client, define a route, define a function for that route. This is where it will appear on the web. Grab the parameters from the query string, get the data, dump it as JSON, and return, run the app. So Flask is great. It looks like that, but if you get a JSON plugin for Chrome or whatever, which I recommend, it looks prettier. So then we're on to tables and charts. This is how you make a data table in PySpark. So we register the Parquet file, or sorry, we load the Parquet file, register it for SQL, and then this is just, it's very direct using Spark SQL. You just call spark.sql, run your SQL. That gets us a data frame back. We then convert that to the old format and save it to MongoDB. So that's the data for our chart, and we published it to Mongo. And then plotting the data, sorry, that's the data for the data table, not the chart, although it's similar. This is the controller for Flask. Mongo is great. This could actually be quite complex in something like Cassandra, sorting the data. So that's why I use Mongo, because it's dead simple. And we render the template. This is the template. It's mostly HTML. You loop through the flights and plot a row and an element of that row. And that gets you this. So none of this is very complex, but it forms the basis for the higher levels. This is the code for the chart. This is the same thing, but we return JSON instead of render the template. This looks complex, but I copied this from an example from Mike Bostock and edited 3 lines. And that's how everyone does everything in D3. Most people don't really talk about it, but 95% of the charts out there in D3 start as an example by Mike Bostock, and they're very easy to find. So that gets you this. We've highlighted the mode. July is the most popular month for flights, although it's fairly consistent. So beyond that, we start to build reports where we explore data through interaction. This hasn't been updated for airline data, but start with a home page. Search is a great way to get started. By the way, this is how I think you should do data science. Everything should be an app. So, there are tags are a great way if they don't want to search. And then you have pages for individual entities. So like airplanes, flights is obviously one, routes, airlines is one that I'll show you. And they link between each other, providing drill down and interactivity. So this is the home page, just as the page about airlines that acts as the home page. These are, I should probably put the name, but these are the airline codes for all domestic airlines in the US. I don't know why they're there twice. I probably stored the data set to Mongo twice. It doesn't do a lot of checking like that. It could, but I don't have it set up to do that. This is the airline entity page. So as I said, we pull the description from Wikipedia, which it makes extremely easy to do. It links to airplane pages by tail number. And those in turn links to the flights by that airline. And it just keeps going to provide interactivity and drill down. The other thing that's great for reports is search, which ElasticSearch makes easy. We do have to do a bit of housekeeping to provide like previous and next. I couldn't find a good plugin for Flask, so I actually had to implement this. You could just use what I wrote, but it was a little bit of trouble. And then, so we also start to characterize entities as a whole. So this is the airplane's page. We're characterizing the US fleet. This is the first iteration. Everything in data science takes iterations. So here's the second iteration where I got rid of all the tiny values because I didn't really care about them. I was more interested in who makes up the fleet as a whole. You can see here, McDonnell Douglas, it appears multiple times and it overlaps the other label. So this third iteration gets rid of the overlap. And then the fourth iteration does entity resolution to remove the duplicate McDonnell Douglases. Now, entity resolution is really hard in general and really complicated and could be its own talk or series of talks. But in this case, I got away with just saying, okay, what are the first 10 characters? And let's group on those and then project the most common tag. So that's a trick you can employ. And then we get a chart that sort of is telling. Boeing dominates the fleet, but Airbus is a good second, and there are tons of small planes by Bombardier, Embraer, and McDonnell Douglas is like the MD-80 series entirely, I think. So the next level is predictions, predicting the future for fun and profit, where we curate, wait, I already said that. So the architecture for the backend for this is that we have historical data on HDFS or in the cloud. It's actually on your computer in the book, but locally. And then we use Spark in batch mode to train the model. We persist it to disk, and then in Spark streaming load it so that it can respond in real time to Kafka and apply the model on real-time data. And it works really well, actually. This is sort of the power of Spark. You might have to use a separate tool in another system or something like that, and re-implementing a model or creating your own way to serve predictions from a model is not a lot of fun. It could be easy, but it could be quite hard.
Question?
Yeah.
So this discrimination between batch and real time, I believe the newer version of Spark, I think it's in the...
It blurs it. It blurs it.
Basically, they will decide how to do it. You just decide a model. Is that correct?
There's a new type of asset. I forget the name of it, but it will... you can, for instance, point it at a place on S3, and if new records come into the files that make up that table, that'll process them as a priority. And so you sort of get both. Yeah, that's a new thing that I haven't used yet.
Is that on the horizon, or is that way away? Or?
I think it's brand new, so I personally haven't used it, but I think it is part of Spark 2.1.0.
I see. But if you had that, a lot of your things get simplified quite a lot.
So this would still probably be the same because it's possible to train predictive models in real time. It's called active learning, but it's much harder, and you can't as easily do it. And so I think you would still train in batch. And so this would be the same. But definitely for many applications, that's a new and interesting way to process data. And so the front end's design, there is a web page with a form, Flask, and we have JQuery, which when you submit the form, you have to fill out a few fields, and it submits it to Flask. Flask then has the job actually of adding all the fields that are in the training data that aren't in the form. Like for instance, the day of year, the day of month, these are features that I added. And so it then submits a request for a prediction as a Kafka message in JSON. Everything is in JSON because I've never regretted using JSON ever. And I have regretted using Avro, Thrift, and all of the other formats I've ever used at one time or another. And so like if something doesn't fit into a JSON message, just put it in a blob store and your life will be easier. That's my philosophy. And so Spark Streaming, reading from the Kafka queue, responds and makes the prediction. It stores it in MongoDB. In the meanwhile, this guy got a UUID from this endpoint that points him at a new URL where he polls every second, or however long you want, and it responds with the prediction when it arrives. And in the meantime, it just polls. And so a big part of building this model was string vectorization. So you tend to start with data that records have fields, and they are either numbers or strings. What you need them in to do machine learning is matrix or vector format. So in vector format, each row is a record, and each column, if it's numeric, is a number. But if it's like carrier, it's a string or nominal or categorical, you have to perform the hashing trick. So every unique value of that field gets a column. So Delta gets a column, American gets a column, but only American is 1 for that number, for that row. Delta, Northwest, they're all 0. Same thing for destination city. Atlanta is 1 for this record, but SFO, ORD, these airports are all 0. So this is the 190 lines of code to train the model. Note that scikit-learn was 166 lines. So for 24 lines, we get the ability to run this on as many machines as we want, which is, I think, a small tax for that ability. And I think this is at least as clean as scikit-learn, although it's not quite as featureful. So if a prediction works, if it has a lot of value, then your job becomes to optimize it, or it becomes someone's job. You know, it could be a whole team's full-time job, like with people you may know at LinkedIn. It drives the entire business, and probably at Facebook. And so it started out as one person. Once it worked, and then it grew to this huge team that optimizes it. This is the performance of the model at some point. Once I so you have to then set up an experiment so that you can make one change to the model, run the experiment, and then check if it helped or not. And so there's overhead to do that. That is approximately through here. So it adds quite a lot of length. And then the rest is me adding 3 features to the model. So there's a lot of ways to improve a model. You can also search for hyperparameters, things that aren't optimized by the machine learning. So you have to sort of search for them at random, essentially, to figure out. Probably like a PhD data scientist would know what each one means, but I have no idea, so I just search, which is what pretty much most people do. But yeah, so it gets more complex, but it's still not that much to do. like for instance, I was able to build a collaborative filter in Spark MLlib in 20 lines of code. So that would recommend content based on a history of recommendations among many users. Literally 20 lines of code. So it's in some ways more powerful than sklearn. Wow, I got through it. Okay. This is me. And any questions?
If you go back, yes, this one. So, if we had the domain knowledge, right? Somebody had the domain knowledge, say, of what is right thing. Could this have been made as a predictive service, where the final airline company basically is giving in and they're able to find what the end results are, but the part of running this sits outside of another company, which actually is letting you do that rather than.
Yeah, so the book covers everything from researching the algorithm to deploying it into production. So you could literally take this and use it and then try to sell it to an airline. It doesn't perform very well.
Okay.
But yeah, it's all there. Yeah.
Any reason that you kind of doing Juniper notebooks if it's in a kind of exploratory phase? It seems there's a lot of graphics, there's Python, easy to play with data. Any reason that you skip the whole set of tools?
Oh, you mean by using PySpark as opposed to?
No, I mean Juniper, basically.
Oh, Jupyter. I'm trying to integrate Jupyter notebooks into this process so they're served from the same Flask process and they just link in. But I haven't gotten it working yet. Yeah, so they definitely have their place. They aren't interactive and you can't drill down and you can't search, and so they're somewhat limited. And you can't serve predictions, but for reports and like there are some, we use them in the book actually, like to create the initial model. There's charts and things where, so that, yeah, I think they're awesome. But, and I'm trying to integrate them into this whole stack, but I haven't gotten it there yet.
Yeah, I wasn't thinking about it. Final application, initially when we go.
Yeah, they're awesome.
Things like that. If you could all integrate into final application, that would be even more awesome.
Yeah, and then ultimately, if I started to think about how to build tools that enable this process, you know, so sort of that might be one of them, the ability to kind of take something from a Jupyter notebook and then turn it into something interactive, you know, something by adding some annotations. I'm not sure, but yeah. Anyone else? Okay, thank you very much.